Hello everybody, I just want to make a short video to update you on the progress of the Quantel Paintbox. So I'm going to talk a little bit about the debugging process that I've been through to sort of try and figure out what's wrong with this this board, or potentially one of the other boards that's in the box. Now, I did speak about some of the things I did before in my previous video. So yeah, I did all the obvious things like checking power supplies. I reseated all the boards, I reseated all the socketed ICs, all that sort of stuff. It made no difference at all. Someone also mentioned checking all the pins, that there is good connections between the boards and the back plane. I've not really checked that because there is quite a lot of pins. Yeah, there's probably 1,000 or so pins that I would have to check, and it's going to be a bit awkward on these, because they're actually three runs of them, and it's going to be just a very time-consuming process. But what I have done is, when the boards were installed, I've tried wiggling them, moving them around and stuff like that, just to see whether there might be a bad connection somewhere, and it doesn't seem to affect anything at all. Any sort of movement or pressure on any of the connectors doesn't seem to affect anything, so I think that might not be worth looking into just yet. So all of the work that I've been doing so far has really been through the diagnostic port. We have a serial port just here. This is also on the rear panel that I've connected to. This has a basic command prompt system in it, so after it powers on and it shows the bus error that I'm getting, it drops into a little a command prompt which has a very limited little menu, and allows you to do a few things like reading and writing any location in memory. You can access the boot files that are on the hard disk, you can enter S records, and you can execute them. So there's a few little functions in there which have proved quite useful to start getting a bit more information about this, given that we don't have any documentation at all. So from the diagnostic port, the first thing I started doing was just poking around in memory and just seeing what does what I can see, and it was pretty easy to find things like the ROM, which appears at starts at 0, memory location 0, and then works its way upwards. So that wasn't easy to find. That wasn't hard to find, I should say. I suspected the NV RAM was just after it, and that has turned out to be true as well. And then from there, I just sort of started looking through, finding patterns in memory, just noting down memory boundaries and where things might look like they change, and it starts to build up a bit of a picture. Now, at the same time as that, Nicholas, who lives in Australia, he offered to disassemble the ROM for me, which he did. I've taken a copy of that and sent it over to him, and he's done a nice disassembly of it, which allowed him to go through and start identifying some of the hardware components. Obviously I gave him a list of the various hardware items on here, like the MFP, the 2 UARTs, we've got the SCSI controllers up here as well, the DMA controller, and things like that. So from disassembling the ROM code, he was able to identify where some of these devices are mapped into the 68,000 address space. Now, one of the things we needed to do to sort of make any progress at all was try and identify what the CPU was doing when it caused a bus error. Unfortunately, the bus error handling code in the standard ROM, it only outputs bus error. It doesn't tell you anything about what the CPU was trying to do, or any memory locations or anything. It just reports bus error, so it's not really that helpful. Thankfully, Nicholas managed to write a few lines of S record, which I could input through the console debug port. We loaded that into RAM, executed it, and that allowed us, the next time that a bus error occurred, it would drop into his code, and it conveniently outputted the program counter and the memory location of the of what it was trying to access when the bus error occurred. Now, at the same time that he was writing that little bit of code, I was also mapping out the debug port. Well, I assume this is a debug port. Basically, all the pins on the 68,000 are come out to this this connector here. So I managed to map all those out, which allowed me then to connect my logic analyzer, which arrived a day or two later. This is a Handtech 32 channel unit, so that allowed me to connect the address lines and a few other lines up to the CPU, and then I could actually start triggering on the bus error pin on the CPU, and allowed me to capture exactly what the CPU was doing in terms of looking at it from a hardware point of view, rather than the software approach that Nicholas did with the software. They both confirmed the same address, which was great. Okay, let's have a look at the memory map that I've done so far. So the address space starts at 0, obviously, where we have the ROM code, which is the two 16K EPROMs, which are interleaved together, so you've got high and low bytes. That is 32K, so that extends up a short way into the address space. We've got a number of copies of that, then a bit of dead space, and then we have the non-volatile RAM, which is two devices which are interleaved together, just like the EPROMs. So we've got 4K of non-volatile RAM there, mapped in at 040000. There is a few copies, reflections of that as well, and then another little dead space. And then we have what I suspect is the beginning of the actual RAM. Now, from 08000, this is a small space which always gives a bus error. Now, looking at the binary of this, I kind of suspect whether the RAM should actually start at 080000 rather than the 100,000 here. I just don't understand why you'd have RAM starting here when you have it here. Surely it's actually an easier way to decode to start from here. So I suspect this is a suspicious bus error as far as I'm concerned. I think that should be a small section of lower RAM which isn't accessible at the moment. So just after that we have the main block of RAM, which is 14 or so megabytes worth. That's all perfectly working fine. I can read and write to that, no problems at all. And then after that we have another suspicious bus error region. Again, I think this should be RAM that's all just part of this block, but it isn't. It gives me a bus error. So that is suspicious as well. After that we have the memory mapped peripherals. So this is things like the UART and the MFP, the SCSI controller, DMA controller, and all that sort of stuff. They all seem to be mapped above this address here. So some of these devices, we don't know what they are. The reason why I have entered these addresses in here is because we've seen them in the ROM code. There's certain values being read or written to. So I've just made a note of them in here, that they are significant addresses, and they do map to something. So for example, here we have one of the 681 UART, that's mapped in just there. We have a memory location for the debug LED display, which is on the CPU board. You can write values to that, and it does indeed change the output of the LED display. We've got another unknown device here, don't know what that is. Just here we have the MFP. Now that is that provides the debug console port, so that's just mapped there. Then we found the DMA controller mapped in just there. So as you can probably see, the boundaries seem to be occurring at we've got F00, F10, F20. So there seems to be like nice boundaries that the devices are being put onto. Next one we have the SCSI controller at F40000, and then we have a number of these locations which are accessed as well. Now we don't actually know what these are, but they are accessed in the ROM code, as I mentioned earlier. I suspect it might be the second SCSI controller, but that's unconfirmed at the moment. So we've got a few regions where it looks like there's a different pattern. This one in particular has no write access, but I can read it. The way I test for this is quite simple. Using the monitor, I can just write a particular byte into a location of memory and then read it back. If it comes back what I wrote into it, then it is read and writable. If I try and write something into it and then I read it back and it's different or it hasn't changed, then it is only read only. So we've got some more unknown memory locations here. These are probably going to be mapping out to some of the other PCBs in the system. Now this is the memory address that I'm particularly interested in, because F96000 is the location that causes the bus error. In the ROM code, it writes a byte to that location and then goes through a little wait loop and then reads it back to see if it's changed. I suspect this is probably initializing some hardware device or something like that. Now as soon as you try and read or write to that address, it just bus errors, so that entire region there is completely inaccessible. So that is this is the area that I've been concentrating on the most. So we've got a few other locations here as well. We have a couple of rotary encoders which are on the board. Those map to these addresses. So as I adjust those, the values in these address spaces here change. A few odd little things. These are just unknown hardware devices, so I'm not really sure what they are. We have a funny location here, which is interesting because we found some code in the ROM where it writes and then reads back some data from this address and does some kind of encryption routine on it to see, I suspect, whether it might be just testing that the hardware is genuine or something. I don't know. And then we had a few other little areas which we don't really know. They're obviously hardware addresses that are used for something, but we have no idea what they're for. And then right at the end of the address space, we've got another bus error. I'm not too concerned about this one because there's no indication in the ROM code that it's used, and it's right at the top of the address space, so I wonder whether that might just be completely normal, but we'll see. Okay, so that is the memory map as far as we understand it. Where do we go from here? I have put some feelers out onto a few forums asking questions about the Quantel Paintbox, and somebody has replied, and it hints that they may be able to have access to all of the information I need. But unfortunately, he has not responded to my reply, which was a couple of weeks ago. So I'm not really inclined to start delving into this, trying to map out where the F96000 address maps to. I suspect it's going to be on one of the cards on that plug into the backplane, and it's not going to be on this board. Now there's a whole load of 7.4 series stuff which does buffering from this board onto the backplane, and then buffering off the backplane onto the other boards. So it's going to take me a long time to be able to try and figure that out, given that I'm a bit of a newbie to this and I don't really know what I'm doing. I think I would rather wait and see what concrete information I might get back from this guy. what I don't want to do is spend hours and hours and hours, and then for him to give me the schematic and the service documentation for it, and I've essentially wasted a load of time. So I'm going to leave it a little bit yet, see if I can get some actual real information on this. If that doesn't come through, then yes, I'll probably start tracing out all of the upper address lines. Now, one other thing that I've done, the EPROMs that were installed in this were one-time programmable, so I couldn't really do anything with those. I've bought a couple of erasable devices and written the ROM code to this. This possibly might give us an option in the future to write some custom EPROM code to help us debug it, possibly. So I've got that as an option. Right, so that is pretty much it as it stands at the moment. It's literally just a case that I'm waiting on the potential of getting these schematics, circuit diagrams and stuff like that, which would help me trace out which components might be at fault with those upper address lines. So yeah, I'm just waiting for that really. If anything does happen on that, obviously I'll do an update video. If it all goes pear-shaped and I don't get any response at all, then I might start looking back at this again and actually doing this the long way and tracing out all those address lines to the buffer chips and then off into the back plane and then tracing that to the other cards in the machine. But I don't really want to do that because it'll probably take me ages. Okay, thanks for watching everybody. See you on the next one.